Good afternoon, class. We're going to go over part 3 of our series of force problems. This is coming from momentum problems part 2. So if you're following along, this is going to be number 11. So we're going to use our equation for force, which is F equals delta P over delta T. And as I'm doing number 11, we filled in all of our numbers in green. So we don't know what the time is, but we know that the change in momentum is 6 kilograms per second, and we know that the total force is 45 newtons. So let us begin. I start like I always do, using the shortcut method as I've done over here. And what I did is I just plugged in all of my numbers directly from the first line into the equation here. So F is 45, delta P is 6, and we're left with delta T in the denominator. Now, this is the part where I say I don't like this delta T in the denominator. So what I need to do now is, because it's being divided, I'm going to do the opposite operation to it and move it over to the left side of the equation by multiplying both sides of the equation by delta T. So I get 45 delta T equals 6. And, well, now it's time to isolate the delta T. So in order to do that, I do the opposite operation that's being done to it. Right now, the operation being done is multiplication. So I do the opposite, which is division, and I divide both sides of the equation by 45 So what I get is that delta T is going to be equal to 1/9 seconds. And like I've said in other videos, this notation is perfectly fine. You do not have to change this into another into a non-terminating decimal, because this is definitely not a non-terminating decimal. So there's no need to turn it into a decimal, just leave it as a fraction. This is perfectly fine. One of the things that I did want to mention, since we're talking about this, is to point out the fact that this is a fairly short-ish collision. This would be an example of if I were to say, let's say I caught a football that was moving fairly quickly at me, because it has a fairly large momentum. Footballs don't have a lot of mass. We can assume, for example, that this would be a football, maybe a football's maybe a kilogram, and they're throwing it at about 6 meters per second. So to catch it in 1/9 of a second, this is about what an NFL or even a high school football player would catch a ball at, in order to make sure that it doesn't bounce out of their hands. So this is generally a force that you can catch it, or something that your hands can hold it, like they teach you in football with soft hands. You receive the ball like this. You could do this in football. This could be even in basketball, where you're receiving the pass, or really any sport where you're trying to actually catch something. So this would be an example of that, if you wanted, just to give you a little mental picture of what's going on in this problem. Of course, some of my other examples are also very much in the realm of ridiculous, because I just made up, most of those problems, I just made up the numbers. So sometimes they're not within the realm of possibility, but I wanted to highlight this problem because it is within the realm of possibility, and something that you actually see quite a bit when you're playing sports. So that concludes how to deal with a force problem using momentum. Good luck in your studies, and may the force be with you.